All right. Hello, everyone. I'm Aditya, and on behalf of Seattle and AppCare, I just 1 minute. I just there's some issues. Yeah. Hello. Yeah. So I'm Aditya, and on behalf of Seattle
All
and
right. Hello, everyone. I'm Aditya, and on behalf of Seattle and
I, right. Sorry for the issues. So yeah, on behalf of Seattle and AppCare, I'd like to welcome you all to the second day of our symposium on AI. And we hope that you enjoyed yesterday's talks, and we have some more amazing speakers lined up for you today. So without further ado, I'd like to introduce Bhargav. Bhargav is a Bhargav is a research fellow at the Knowledge Lab at the University of Chicago, and he works and his he researches on the structure of knowledge prediction and society. And his talk today is on a very fundamental topic. He would be talking about research at the intersection of AI and the social sciences and humanities. So, and also Bhargav is a Vitsian from the 2013 batch. So he's he has kind of a personal connection to our batch, to our campus. So welcome Bhargav, and let's get started with the talk.
There's some feedback, but okay. I'm going to start. So if there's some problem with the mic, can you please type it in the comment box right now? It's a bit strange. Okay. I'm going to just share my slides. Um,
You're on mute, Bhargav. We can't hear you.
can you
I guess you should just reduce the sensitivity a bit for the mic.
the sensitivity?
Yeah, it's you kind of have a audio feedback loop.
If can everybody else switch off their Hey, can you just, if people can type in the chat if you can hear me? Hey,
Yeah,
can you?
I think it's good now.
Okay, if everybody else can switch off their mics.
It's just me and you, so great.
Hey, okay. I'm going to share my. Okay, so let's begin. I'm sorry for that whole whole issue. It was weird. I was in the green room right before this and it was working, so it's strange. But okay, hello everybody. My name is Bhargav Srinivasa Desikan, and today I'll be talking about research at the intersection of AI and social science and humanities. A little bit about me to give you context of who I am. I'm a research fellow at the Knowledge Lab at the University of Chicago. My research interests are in the philosophy, history, and sociology of artificial intelligence. I have authored a natural language processing textbook, and research which I was a co-author on has been published in the journals Cognition and Journal of Machine Learning Research. And that's my BITS ID. It was a 2013A7TS053G. And just some things about the slides. They're kind of like a table of contents to kind of help us keep track on where we're going to be. But I'd be happy to give you all the links and references to the literature used if you mail me or get in touch with me. So what this talk is not is it's not just a summary of the relationship between AI and society. That's a really massive and complex relationship. So what the point of the talk is, how can we better understand the relationship between artificial intelligence and society? And what are the different ways we can get at this difference? How do you get at this relationship? So specifically, this talk is a way for us to showcase two ways to study this relationship between AI and society. And it's to use artificial intelligence and machine learning methods, which I'd imagine most of you, if you've attended yesterday's day as well, to have a fair amount of idea of how these kind of machines work in general. I'm not going to go into a lot of specific details. And also how we can use the social science and humanities to study AI and machine learning. So it's from two ways. We're using AI and machine learning techniques to study the social science and cognitive science. And in one, we're using social science and humanities to study AI and machine learning. The talk is going to be about examples of research which I have either been a direct part of or research which has deeply influenced me. So the reason I'm giving this kind of pre-qualification is for us to better organize the talk. It'll basically be in three parts. The first two parts will be research which I was directly involved with, and it'll be an example in computational sociology and computational cognitive science. So that is computer science applied to these fields in the social sciences and humanities, right? So that's one section. And the other section, which is the last section, will be research that has deeply influenced me and is research from the other side. Like, how can we think critically about artificial intelligence, machine learning, and its relationship with society? So the first project, which I will be getting into, like I said, there's going to be three main flows, three main ideas, which we're going to be dealing with. And the first one is the project is titled Flows of Knowledge. This is my master's thesis. My master's thesis is a part of this. We are funded by Burning Glass, which is a jobs and skills analytics company. So they study how exactly across a country. I mean, in this case, is the context of the US because the company is an American company, but you can think of the same kind of analysis to India as well or any other country. And basically, you study how in the job market, like how is what is being taught in universities being met with the job market and being met with research and these ideas. And the work is a part of the Knowledge Lab, which I'm a research fellow at. And the work is supervised by Professor James Evans and Professor Louise Betancourt at University of Chicago. So that's just to give you some context of
where this work is coming from, right? Which I think is very important whenever you look at any scientific issue. You should kind of understand the context of where it's coming from. So the main question which we're going to be looking at is how can we study the knowledge economy? Now, the knowledge economy is the kind of economic system which we are kind of dealing with today, in a sense, at least in terms of, in our context of artificial intelligence researchers. You have basically, you can think of it as universities feeding this knowledge economy, where you have universities, not only like giving birth to research, but also teaching students how to do this research. You have professors teaching, organizing, events like this. So it kind of contributes to the knowledge economy. And then you have highly skilled professionals in, using this, again, highly skilled in the context of this particular AI, or, in this part of the knowledge economy. So this is just one aspect of the knowledge economy, but in general, it's how these kind of economic aspects to do with highly skilled labor. You can think of like computation as an example of knowledge economy, and even the managerial class to a certain extent. So this is kind of the context of what we're trying to measure, what we're trying to understand, what we're trying to study. We're trying to relate research at universities to what they teach. So the kind of research which your professor is doing as versus what they're teaching, how much does it match up? Does it need to match up? These kind of questions. How does industry research and academic research relate to each other? Is one more oriented towards certain kinds of results in the market? Is that a good thing or a bad thing? How do those comparatives happen? And see how spatial similarities and semantic similarities affect research. Now, what does this mean? Spatial similarities would mean like the same city or the same state or the same country. And you have a semantic similarities, which means the ideas. You can think of semantics as, how do you measure semantics? Semantics is meaning. That's what semantics kind of means, and it's the semantic sense of something. So the way, in our context, the way we look at it is, let's just choose a university and think of an example. Even if it's like BITSCOA, right? So you have the biology department just doing maybe research on DNA, RNA splicing, and whatever kind of work in computational biology. So it's creating a computational biology semantic vector, and you have vectors of maybe if it's IIT Kharagpur or something, you'll have maybe metallurgy if they have those kind of courses being offered. So you can think of every university to have certain kinds of semantics associated with it, and we measure this using multiple ways. Now, a popular way of measuring semantic sense is word2vec and doc2vec, which are two standard algorithms in natural language processing. I won't go into a lot of detail in case people are not very included, but it's basically a way to get a mathematical representation of a word. And similarly, you can get mathematical representations of documents. And I use these methods to create semantic vectors of research, teaching, and industry. And I use these vectors to measure relationships between these different entities here. So the idea is I want to study how universities and cities work in the knowledge economy. I create vectors using AI and machine learning. And I see, do universities in different rankings, different scales, do they teach or research differently? What makes them different? Do universities in different states and countries, do they teach or research differently? What makes that difference? So these are the kind of questions which we are, trying to answer. And I won't be going into more specific details and results because this is an ongoing research project. But hopefully, we should have some work talking about exciting research. And, until then, I'm happy to chat more about this in detail. But this work is kind of allows you to, have a framework to study these, previously qualitative ideas in a more quantitative way. It doesn't mean that this is a perfect quantitative representation, but it now means we are at a time where we can understand, like, what does a university produce as an output, or what does a university teach? To understand this in a semantic sense and then measure it. This is something which can only happen with really the advent of AI and machine learning. And this includes an idea of using natural language processing to deal with the sociological issues. So this kind of falls in the realm of computational sociology. And now we'll be moving on to the second, kind of project, which is to do with computer science and social science. But this time it's it's cognitive science. And the project which I'll be talking to you about is called Computational Synesthesia, or CompSyn for short. So some context for where this project comes from. It's from the Santa Fe Institute, the Complex Systems Summer School of 2019, which is last year. And we are 6 scientists and 1 painter, and 2 of us are Bitsian alumni. Abir Abubakar Kar, who is 2013 alumni. And he's also at the University of Chicago doing a master's in computational social science. And me, I'm the second Bitsin alumni here. And yeah, that's the context for this work. And this work has been published in the journal Cognition, which is a leading cognitive science journal, and it's currently under review at COLING, which is the Computational Linguistics Conference. And the basic idea is we're trying to uncover relationships between words and colors. And we go through this one particular pipeline, which is we use Google image search to get 100 images of a word. Now, before that, I should probably give a little more context on why are we looking at words and colors. So at least in the context of English, and I'm sure honestly, depending on the language you can go into, you can find strong associations of this, but words have an association with colors in an almost synesthetic sense, such as anger and red. You have like a fiery rage and this kind of red feeling. For jealousy and envy, you have this green kind of feeling, and so you have a strong association of words and colors in different kinds of domains, and we're trying to basically better understand this. And the way we use this is what we use Google image search to get the top 100 images of a word. We create a human perceptible color distribution of each image, and then average all 100 images for each word. Now let's just slow down and figure out what this is about, right? What exactly do you mean by human perceptible color distribution? In this context, it basically means that when we look at an image and scan it for, say, something like deep learning, you're trying to do some image classification, you normally look at RGB values. Now, this is a way for a computer to understand the distribution of colors, but it isn't as humans how we distribute. We don't look at a color and say, oh, that's 30% RGB or something. We perceive colors in different way based on hue and brightness and color as well. So this is a human perceptible color distribution. So the color transformation happens in a nonlinear way from RGB to JZ, AZ, BZ. And now we have an average color distribution for each word, or a color vector. Now, using this color vector, we can demonstrate the synesthetic nature of words. Like, how do words have certain colors? Now, this is the only slide in my presentation with an actual diagram or something, but I thought it was really pretty and a nice way to demonstrate what's going on. So you get the terms from WordNet, and you get these hierarchies of where words stand. You collect the top 100 Google image searches results. You kind of condense them using this transformation, compute the color distribution, and then you cluster these, and then you start to see there's certain kinds of patterns. What kind of patterns? We notice that abstract semantic domains have statistically significant color associations. What does this mean? For abstract concepts like democracy, happiness, mathematics, the average color distributions cluster within these categories more than they would on average randomly. So for example, in music, you have blues and disco music clustering together. You have techno and metal in another cluster. In academic disciplines, you have history and literature in one cluster, and then you have computer science and physics in another cluster. So you start to see, and you can look at the other diagram over here. If you look at D, you can see how concepts cluster in color space, which is really quite fascinating. And we created 40,000 color vectors, which took like 3 weeks of computation to create color embeddings. And this work is currently under review at COLING. And the results are pretty exciting. And I'd be happy to share once the paper is out publicly. So we spent some time thinking about how exactly you can use computer science and AI to understand the social sciences, right? You're trying to understand sociology or cognitive science. How does the brain think of color? How do we understand knowledge? We're using AI to help answer these questions. So AI can, it's clearly useful in one direction. It's useful in the direction of trying to use massive amounts of data to understand things. And now the things we're trying to understand in computational social science are the social sciences. We're trying to understand sociology. We're trying to understand social processes and social theory. How do people react with each other? How do networks form? Who becomes whose friend? And this is useful for social networks, for example. Then you think of history, for example. How can we digitize records and find patterns throughout history? You have cognitive science, where you can think of, how does the brain function? You have economics, you have psychology, and you have a wide variety of disciplines in the social sciences, which we're using AI to answer. Now, this is one way you can understand society through AI, but what about the effect which AI has on society? Now, this is kind of the second half of the talk in a sense. And now we want to be critically thinking about AI through another lens, through a lens of science and technology studies. Now we're going to kind of shift gears where I gave you, previous examples of AI and machine learning doing all these cool things in the social sciences. Now we kind of shuffle around and we shuffle the paradigm, we flip the paradigm. We use ideas of anthropology, sociology, science and technology studies, which is called STS on the short form, and critical theory of philosophy to study how AI not only affects society, but how do AI researchers function? How do we function? What kind of problems are we trying to solve as a community, as a scientific community? There's a wide variety of very important literature here. And please email me, and I'm very, very happy to send you a list of the kind of literature and books. But basically, the question which we're trying to explore is what is the social nature of artificial intelligence? And what does it mean for like how can a science be social? How can what is considered a hard science be social? And a lot of us are working with Gaussian processes and different kinds of optimization procedures for error rates. Like, what is the social nature of AI? So let's think about AI in society. AI is used in systems such as prison and surveillance. Now, this is obviously has very dangerous implications. Um, let's think of whether someone should be given bail or not. Now, in the US, now this is the context of the US. Some of these examples which I'll be given are a little more American, and the reason is because America is one of the first places where AI is actively used in society, and then other countries are still catching on. And there are, excuse me, there are obviously with the example of even for India, you have a lot of examples which are super relevant, but we'll use a mix of examples. But these more or less they carry on, right? They carry over these boundaries and countries. But AI used in systems such as prison for granting bail, it's been shown to be explicitly racist. The kinds of numbers of suggesting someone should not be granted bail are significantly higher for populations of color and non-white people, specifically African American populations in the US. And it's been kind of shown to algorithmize the racism in a sense. And now you might be wondering, like, how can an algorithm of this sort be racist? Well, the main reason and the fundamental reason for these kinds of issues are the fact that human society in the past has been racist, and this kind of systemic racism doesn't go away easily, even with laws being passed. It takes a long time, and racist data persists. Racist data persisting is suggesting that certain demographics commit more crime, and those areas should be policed more. So when you're going to use it for surveillance and policing, you're using racist data just because the human experience we've had is racist, and you're kind of making those more powerful in a sense. And bail is an example where you have racist biases coming up and further making the system difficult for people who don't have privilege and power. AI used for computer vision to scan faces, and in general, basically, it's a complete violation of privacy rights. And this whole place is fraught with a lot of human right violations as well, of how much can a state or even corporations choose to have in terms of our visual data and how we look and how we live our lives. AI used in finance and banking. You can think of AI giving loan decisions. Now, you normally have interest rates being decided by AI by a variety of factors, but what ends up happening is, and this happens in all over the world, segregation allows certain parts to be poorer and certain parts to be wealthier, and this is a function of unequal wealth distribution. And what ends up happening is you have richer people getting easier loan decisions, and you have poorer people who are already in poverty getting even more difficult loan decisions. And this system is entrenched when you have previously racist or problematic and biased data, when it's used to create new models and you continue to give bad loan decisions. You have AI used in photography and tagging. You've had examples of racist cameras in the sense of the skin detection algorithms for deciding when you recognize a character on the screen is different for people of color and white people. And based on the color of the skin and based on the lighting at the time, you can have very different results. And it's been certainly geared for those who already are in power. And for those who are not in power, and minority groups are usually having to come from behind and ask for certain rights when it comes to equal representation in data. You have AI based on personal data used for micro-targeted marketing being very problematic. You have political advertising, which can be used to change decisions. Cambridge Analytica was possibly one of the biggest issues and examples of this, where we had models made out of our personal data and then political decisions being made for that, which is just a clear violation of our rights and privacy, and political interference, which is just using artificial intelligence. These are all just some of the examples in which, whether we like it or not, you have artificial intelligence directly affecting society. And there's more. Data reflects human biases. There's been a paper published in Nature as well, or Science, not sure, but suggesting that that corpora used for machine learning does have human biases, and these get propagated. Questions of privacy, consent, and ownership of data and the ethics of data is problematic, with sadly the big corporations mostly having the way, and we as individuals not having a lot of property rights. Europe tends to look at this more critically with the cases like GDPR, but this is still a complicated stage of discussion. Representation in healthcare and medical data sets, the huge problem with, again, those who have capital and those who have power kind of deciding who these medical data sets are built for. And you don't often have a lot of representation for all different kinds of communities which require different kinds of healthcare. We have Shoshana Zuboff, who's a Harvard sociologist, and many others, of course, talking about us currently in an age of surveillance capitalism, where you have companies like Facebook and Google using our personal data to make psychological models for more personalized marketing. And understanding the way this works and our lack of privacy or exploitation in many ways and the issues dealing with this is very important and difficult problems to just deal with right now. Now, all of these, things which I suggested, these problems laying bare, these are just a list of problems, but there are solutions. And as people who work in AI, we're very much part of this issue. And these are two recommendations from this area of research. This area of research, again, is called Science and Technology Studies, broadly Science, Technology, and Society Studies, or Sociology of Science. And these two books are two books I'd personally recommend for, I think, as us as AI researchers, it's our responsibility to know more about where we come from. And Beautiful Data by Orit Halpern is a perfect example of that, because this book is a history of data, a history of vision and reason. And it's important for us to understand where do we come from as a tradition of artificial intelligence and complex systems, like, and what does it mean, and what are the political issues with that. I think it's very important for us to understand. Then there's the wonderful Race After Technology by Ruha Benjamin, which talks about, again, it's in an American context, and it talks about the issues of race here, and we can think of similar issues of class and caste in India as well. And it's basically for us to kind of think more critically about this and these issues. In the Indian context, for example, one can remember like Facebook coming in and attempting to give free, very, very cheap data, but then internet to everybody and internet access, but only control the websites being allowed, and having a monopoly on the data there. And there's a lot of pushback from India, and we kind of drove them out. And that ends up being a very important example. Then you have the example of the apps currently being banned in India, for example, like TikTok, which is known to have other privacy issues. So you have this kind of scenario where AI and data and society become very, very strongly interlinked. And whether it's the context of, right now in the US or in other parts of the world, and Europe, and in India as well, in China, we're definitely moving to a different kind of age and time, where as people doing research in these fields, we have to, realize the consequences of what we do. And so what exactly can we do? We can understand that our work is necessarily socially situated. This means that the work which we do as AI researchers and AI scientists is necessarily going to have an issue on the world, an effect on the world which we live in. We have to think about this. We have to critically think of the consequences of our work and its contribution to society. Whether you have an ensemble learning model, which may seem like it's not important, or in some cases you're trying to do some data analysis of Twitter tweets or something. Whatever kind of research we do has a direct effect on the world, and we have to be very critical of that. If you're using class, race, caste, sexuality, and other personal attributes in your data, is it bias free? Is the representation balanced? And also, what are you trying to measure using those characteristics? Thinking about this in a very critical manner and thinking of what the consequences of that can be is incredibly important. It's our responsibility as being interested in this sphere and working in this sphere to make sure that we don't allow a misuse of AI. it's our responsibility as scientists and engineers to make sure that the work which we do is a positive contribution to the world around us. So that was a lot. And this is, the end of the talks, which gives us a lot of time to really deal with questions, or I can go into more particular examples and cases if you all would like. But let's just kind of, catch up here with all of everything I've thrown at you. So there are basically many ways to think about the relationship between AI and society. You can study society through AI. You can study AI through the social science and humanities. But what is truly necessary for a holistic and complete understanding is a reflexive two-way study where you are very, very clear about the implications and consequences of your work, and you use these techniques of critical thinking to think about the issues which we're working on, making sure that we are ethical, especially when some of the legal frameworks haven't built about this, because we've not caught up yet there in some ways. And it's important that even if we are unsure of the legalities, that in good faith, the ethics which we use to go ahead should be important. And think of how AI can move beyond purely money making and capitalist enterprise into something which can work towards AI for social good, AI for governance in a way where you have equal representation, where we think of data and ethics. And at the same time, it allows us to explore beautiful aspects of sociology, cognitive science, and psychology with these methods, as long as we're sure of what we're trying to say when we are doing research in these fields, and we're can move ahead from the kind of humble attitude towards AI and towards the social sciences. We can have a better understanding and balance in the kind of work which we do. And that's it. Thank you for listening. I didn't check if uh, I didn't check the comments. I hope everyone could hear everything. Okay. And my handle is Bhargav Vader. I'm Star Wars fan, so the Vader stuck there, and that's on GitHub for code, Twitter for like tweets and work, Gmail for getting in touch with me, Instagram for any cat pictures. And I'm happy to chat about research ideas and answer your questions now. Thank you.
Wow, that was a great talk. So yeah, I guess we can move on to the questions for now. And we do have a lot of time, so I guess we can like cover the questions very well. Right. So one question by Advait Rane, who's actually a student here at BITS, and it has got a lot of votes, is that computational synesthesia sounds like a very interesting project. And could you elaborate a little more on the practical applications that this might have in real life, maybe in areas like marketing?
Okay, yeah, that's a good question. I'm very happy to. I know what I'll just right now. I'm going to send you the GitHub link of the project. It's called CompSyn, or Computational Synesthesia. So, okay, just a second. So, cool. So that's the link over there I just put down in the chat. If you just want to see the code, I'm the principal architect of the code. I've written most of the code there, and of course, we have a great, awesome team. Like I've written the code in terms of organizing. Just want to give a shout out to the brilliant people who have really, really been a great team to work with. And okay, so what are the practical applications? So the application is actually entirely practical. Now we haven't released this work yet, and I don't want to be talking a lot more about it because it's still a work in progress and it's under review in journals. And there could be somebody here who might see the paper, and it's a double-blind process. But basically, we're trying to create color representations of words, right? So now you can think of it this way: if you're trying to have a natural language understanding system, our natural understanding of language, if we want to have a mathematical representation for this, it will be more nuanced if we add color. For example, if now I say apple and fire truck and I ask you to find the commonalities between them, like red is the obvious common, the link between apple and fire truck, right? So you can now have another way of looking at the relationships between these two words, instead of just being limited to apple and fire truck being, for example, if it's word to vec and then they're far away from each other. These words are actually not so far away, because if I tell you apple and fire truck, you might say red as the example, which is linking both. So by adding this kind of color information of like red, you have a color space, right? So you have a color semantic space. Now, when you can use this color semantic space, you can use it in combination with your word semantic space, and you can have more nuanced understanding. Look at poetry, for example. A lot of artists and poets, when poets talk, the kinds of poetry is supposed to have like colors, right? And you have these. You can think of a visual effect of poetry. Now, you can measure the visual effect of poetry if you have this kind of system in place. So these are just like some of the examples in marketing. I'm personally not very interested in marketing, but if it is marketing, then you can think of what kind of colors are people more likely to buy, and then maybe you can like prime a certain color for different people. Now, that's just an example, but basically you can think of one in general ways. Color improves your understanding of words, and that's a practicalist thing. So just you have word to vec, you can think of having like a color to word to color vec. So for every word, you not only have a word to vec value, you also have like this color value, and both of these values can give an understanding of the word.
Right. And I think another related question by Somesh is that can this be can this be extended by addressing the modality of speech? So we can I think you touched a little bit upon this, but can we kind of correlate speech and its expression in vision to make speech more expressive?
Sure. Yeah. So yeah, you absolutely can, right? It's it's like this kind of research is very nascent right now. Like we're still, I think, a long way from expressing. Like I can see there's a comment. Could you say something about like AI and consciousness studies? And I think that it's like another really fascinating body of research I'm very interested in. But uh,
Right. And we also had some questions. So shifting gears a bit, we also had some questions on the biases in datasets. So one question was that if okay, so we do have these biases. Are there any ways that we can tailor our algorithms to work with these datasets, or can we like modify these datasets in any standard way, which can help us reduce these datasets, the biases? I think the screen is stuck. Yeah. Okay. Mhm. All right. So I guess we should maybe you can reconnect. I guess, or maybe just like start your screen. Okay. Am I audible over here? Is the host audible, or is it just from? Okay, fine. So I guess there's an issue from your end. Uh, are you working with Chromium because Chrome or Chromium because that's kind of a more supported browser? Yeah, sure. Just like join back again. I'll call you back to the screen. If possible, just try joining in with Chromium. That might help.
Hey, can you hear me? Mm, oh, cool. So can can you give me some more? I still don't know if. Okay, cool. So which question were we at?
We were talking about like how you can just use algorithms to like unbias or to kind of reduce the effect of biases in data sets.
Okay. Could hear everything before that?
Yeah, I guess we'll have to ask people. So where exactly did we break off? If anyone like has any kind of landmarks where we should start from again? Did you all hear the question, and then we can like are we good to start with the bias question?
Okay. Oh, all the way from the beginning. Okay. Uh, I'm getting a kind of mixed.
Yeah, I'll just ask. Yeah.
Okay, so there seems to be a consciousness studies question and a bias question.
Yeah.
So I'm going to start with briefly the consciousness question, and then I'll move on to bias.
Mhm.
Okay, cool. Let's start with bias. Okay, enough people are saying bias. I'm just going to do bias. I'm sorry, fellas. Okay. So okay, about bias. Yeah. So first of all, there's like a lot of packages which do this for you. There's literally like Python machine learning. There's something called imbalanced learn, which is a scikit-learn compatible package, which basically allows you to make sure that your classes are balanced. Then there's other packages which literally look at it takes like a word to vec model, and then it picks up things on the gender axis, the race axis, and it kind of makes the models unbiased. So you can literally use a model to make your word to vec models unbiased. And so there's really cool work like this. So there's a variety of Python packages which do this. Just in just doing with Python, there's a bunch of research papers being published in a lot of conferences and journals about how to deal with bias as an issue. And we don't have a perfect answer yet, whether in terms of do we want things prescriptive, like do we want things better, do we want a better future, do we want to just continue to repeat the status quo as long as it's not biased, like what does do we want to fix the inequalities? So I feel that there's like a lot of things which we can do to our algorithms based on the situation which we're in. And the best way to deal with this is this idea of using model scorecards to make sure that your models are not biased off the bat. So use model scorecards, make sure that if your data set has any bias, like what kind of bias, make sure that you explore that and cancel that. Yeah, I'd be happy to share a bunch of papers. I can maybe get a doc and then pass the doc on to the organizers later for more exact references and lists. But you can honestly just go on Google Scholar as well and just search for bias in NLP AI, and there's like a bunch of papers. Again, I would recommend the conference ACM Fact. So ACM Fact is a conference which you can check out for particularly for this kind of stuff. But it's a lot of stuff we have to do, right? Like you have to, like algorithms in themselves are not biased, yes, in a sense. But for example, a classification algorithm, which if it looks at biased data, it's going to keep doing that. So in some cases, you can argue that, yeah, I mean, technically it was a biased algorithm, right? If it doesn't account for the bias inherent in the system. So there's like a lot of different contexts here. And yeah, we're not trying to say like this model is, actively biased, unless you have cases where it's made like that. But it's kind of like a high level of diligence and accountability. That's kind of what we're working on over here.
Right. And another kind of related question, which I guess like got a lot of attention in like the previous 2-3 weeks, was that are only our data sets biased, and so can we just move to a non-biased data sets to reduce the bias, or are our models also inherently biased in some way? Like,
So again, that's like these are like good questions, and I suppose another thing which we want to think of is sure, like are our models are our models itself inherently biased, or is like it's not going to be like random forest underscore racist or some shit like that. I mean, it's not going to be like that kind of active bias, right? And what we're looking for is, and this is a problem as personally as algorithms, as programmers and as scientists, which we deal with is this kind of work which we do in anti-bias isn't something which can happen independent of movement in society. We actively need some kind of societal change, and that the algorithmic change to happen with it. Like algorithms aren't going to fix the issues in society, and if we fix all the biases in tech, it doesn't mean that all the issues in the world which we see will be fixed, right? It doesn't automatically mean that that loan will be better, or that the police surveillance isn't a problem. Like you need to look at the more foundational issues with the problem and try and solve those while at the same time looking at this. So it's you can't just like for example, you want to fix a historical bias, right? Like you think of like what would an ideal world look like then? Would an ideal world look like where everybody was given the same in like an ideal world, if everybody was just given the same outcomes based on what they are, maybe people in need should need more rather than people who already have. So again, like fixing bias in a terms of prescriptive way, like what good can we do? How can we actively change the data? Like what do we want the data to look like then? And if you're changing the data a lot, then is it really like a predictive model? Like what are you predicting on? Are you predicting on a future which you would like to see? Are you predicting on like, so there's like a lot of important questions over here. Again, like I can add some papers and send them on a doc, which kind of from a philosophical angle look at these questions, because it's not simply one line of code or one thing which balances your data and then boom, everything is fixed. It isn't that straightforward.
Right. And I believe that the important thing is that there's no clarity on how we should actually move forward with this. So there's no ideological, like, okay, this is the way forward and something like that.
Yes, I would like to think that, like, I personally believe that we should, again, that's just a personal belief, that we should work towards a prescriptive world, like try and build a world which we want to see. But, what I think should happen and what someone else should think will happen, might not agree. And that's when you have, again, a collaborative process, and you have scientists and researchers and industry experts coming together and deciding how do we want to go ahead with this in a way which is fair and equitable to all, and especially looking care of those who do not have power and who may not have a voice and may are marginalized communities, and specifically making sure that their needs are being met.
Right. Another question is about explainable AI. So can we use explainable AI to, make these black box models more explainable? So if we have a model that kind of predicts the loan, and can we use explainable AI to try to see if there's a bias in this? Because often these models have been described as taking a black box and creating another black box to kind of explain this model. So do you think that has any potential?
Yeah, sure. Again, like great question. Yeah, I absolutely think it has potential. Trying to unblack box the black box, trying to make it more transparent. trying to, if we're using deep learning, making sure that at least we have like a, like a tuning thing where based on, I mean, again, the problem with deep learning is you just throw 10,000 things inside. So it's difficult to find out exactly what's going on. But, like if we can avoid deep learning, can we just, stick with a linear regression, a logistic regression? Like, do we really need to have more complicated methods? And that's highly linked to explainable AI, right? Because I mean, you have that the explainability predictivity kind of diagram, and you say what's more, and I would say like either we have a more sophisticated understand of deep learning, or we continue using models which are simple. I think deep learning can be a wonderful way to explore, certain parts of things, but to make like life-altering decisions, which it's, can be done for a lot of people, that shouldn't be the case. And I think explainable AI, especially when you have just like a, just based on your variables, what kind of effects are, what kind of things are happening. Just looking at those values are important. Having explainable AI in other decisions as well. For example, if your loan was denied, and then you don't just say sorry, your loan was denied, you get a message saying that, oh, your loan was denied because of this value and this value, it changed your factor of correlation by this much. Like, we need that information. So I absolutely think explainable AI is another right step. Like, there isn't again like one answer to all of the problems, right? It's massive systemic change, and for systemic change we need a lot of things and a lot of fights to make sure we're going in the right direction.
Right. And yes, switching up a bit, I think some of the viewers had kind of wanted to know more about the specific techniques you use, about your algorithms, uh, such as like how you actually apply, like you got the connections between colors. And so you did touch a bit, like a bit about it by, by the by taking the data set, but how did you actually kind of get those connections between them?
Okay. So I'm just gonna repeat this to make sure I've understood the correction. You want to know exactly how did I go from word to color distribution? Is that the basic question?
Yeah.
Okay. Yeah. So I think there was that one slide, but I'll just try to, I'll walk you through the example for how to create it for one word, and then you can try and, extrapolate this to all words. Let's say that word is love, for example. So it's love. And what we do is we basically have a bot, which, and all of this code is public in that link which I sent you. So we have a bot which basically searches for 100 Google image search results on just Google image search, 100 images for the word love. We then get an RGB representation of each of these words, of each of these images, right? So say for love, we get 100 images. So for 100, we have 100 RGB distributions. We then apply a nonlinear transformation on these RGB distributions to turn them into this vector space called the JZ-AZ-BZ space, which we like to call JAZZ-BAZ. So once we're in this JZ-AZ-BZ space, and this nonlinear transformation, we do through some research work which was done in 2017 from these people who worked on creating this nonlinear transformation. So that work is used by them. So we use their color transformations. Once we have each of these 100 images RGB transformations, we convert that to JZ, AZ, BZ, and then we create an average of that. So now you have and then we use bins, basically, like if you have the whole image, like we bin that image, and we have 8 distribution values. It's 2 power 3. So you have these based JZ, AZ, BZ, and you basically have this 8-dimensional space. So you have this, so basically word, 100 Google image searches used in from RGB, you convert to JZ, AZ, BZ, which is human perceptible. And then after that, you basically, you have that representation of the word. So that's how you go from word to color. And then after you go from word to color, you can use other linguistics research to kind of structure your questions. And that's what we do.
Great. Right. So I guess that should be enough for that question. And yeah, we do have some more questions if you have some more time. Would you be like? I guess you can. I guess you can have a look over here and like choose whatever you want to answer. So we have, I guess, 2 more questions, and I'm not sure if they're kind of relevant to your work. They're kind of, tangential to it. So do have a look. We have one on cognitive studies and another one on computational psychology, and if there's any way of relating them to your work.
Yeah, sure. So in terms of synesthesia, and like, so you have to first think of like what is cognitive science, right? Cognitive science can be thought of trying to better understand how human beings process cognition or problem solving or concept forming, concept clarification, or how our brain works and solves many tasks. So the way we do this is we there are many fields which contribute to cognitive science. You have philosophy, linguistics, because language is an important part of the way we think. So computational linguistics from that aspect. You have psychology, which is like how does human psychology work, and you have a wide variety of fields. And then I think the real, like, the clever part of these fields is trying to devise an experiment or like a setting. Like in our case, it was, we thought, oh, if we search for a word on Google, then you get all these images. What do the colors of these images look like? So that's how we started thinking about the problem, right? So I think the idea in both cognitive science and psychology is you want to better understand how humans think and perform and do things. Now, there are many reasons why you would want to do this. Like usually it's funded like in terms of trying to sell things to people. Like sadly, what's most of AI is just used to sell things so far right now. But regardless of that, just in maybe better understanding how the human brain works, and even if it can be used for the medical sciences as well, that's an important contribution. And I think the clever part of this whole field is just the way kind of experiments you set up. So even for like computational psychology, so like you want to look at a aspect of human behavior, and then you think of how can I understand this aspect of human behavior, maybe using some kind of measurement. In our case, the kind of measurement or signal which we used were words and colors. You can, similarly for psychology, you can choose your signals, you can choose your information which you want to collect and how you want to think about your information. And if you can computationally represent that, that's what you want to try and do. So I would highly recommend, if you're like more interested in it, just like Google and Google Scholar, like computational psychology, computational cognitive science, and you can get a bunch of papers to understand exactly what this field looks like.
Right. I guess that would be all for today from this session. And I'd again like to thank Bhargav for taking out the time. Yeah. And it was really a great talk. And I guess like I'll have to explore a lot more on this as
Yeah,
well.
I'm glad it was.
Yeah. Great. So see you all in the next session. We'll be starting in around 2 or 3 minutes. Yeah. Thank you, everyone.
Bye.